Problem 179 is another good example for constraint motion. And I would recommend to think about this problem at least for 10 minutes before seeing this video. So we have two blocks here. Both of them are moving. Block B is moving upward. That's what we know. Velocity of B at this moment is 3 foot per second. And also acceleration of it is 6 foot per second squared. And we are supposed to find the relative velocity of B with respect to A and acceleration with respect to A. And also we need to find the velocity of this point, which is on the cable. Like the previous problems, we need to define the location of these two particles, then use the length of the cable to relate these variables to each other. We have different options here, but one of them is this. We can put a reference line here, and I can show this distance with a variable like x. So if I give you x, now you know the location of B. So x shows the location of B. And same thing for B, for A, I can use this variable. Let's call it y. If I give you y, then you know what is A. And I can write the length of the cable in terms of x and y. And because I'm gonna deal with the location of C as well in the second part of the problem, let's call this distance z. Z shows the location of point C from this reference line. The length of the cable is equal to, from here to here is x minus y. And I have two of it, right? X minus y, x minus y. So I have 2 times x minus y. And this part of the cable is gonna be this distance from here to here, which is a constant number because this is a reference line, it's not moving, and this point is not moving as well. Let's call it B, for example. B is a constant number. So this part of the cable is gonna be B minus y. So I have plus B minus y plus bunch of constants, like for example the length of the cable here, here, and here. So B is constant and also C is constant. So it's going to be equal to 2x minus 3y plus B plus C, which are constant numbers. If I take a derivative from this equation, I'm going to have 0 is equal to 2x dot minus 3y dot. Derivative of B and C, they are 0. And if I take another derivative, I can find the relationship between accelerations of these particles. So these are going to be the equations. We know velocity of B is 3. So it is moving upward with the velocity of 3 feet per second. Because of that, x is going to increase when B is moving upward. So x dot is going to be positive 3. So x dot is positive 3, and from there, y dot is going to be equal to 2, and it's going to be positive. Y dot is positive, it means it is increasing, so A is going to move upward with the velocity of 2. And in the same way, we know x double dot is equal to 6. So because acceleration of B is upward and it is 6, so x double dot is going to be 6. And from there, y double dot is going to be equal to 4 foot per second squared. Now to find the relative velocity and acceleration, we only need to write that equation. Velocity of A with respect to B is going to be equal to velocity of A minus velocity of B. And if we assume that's our positive direction, velocity of A is equal to, sorry, it's asking about velocity of B with respect to A. So not the opposite. So velocity of B with respect to A is equal to velocity of B minus velocity of A. So it's gonna be 3 minus 2 is gonna be 1 foot per second along that incline. And in the same way for acceleration, acceleration of b with respect to a is equal to acceleration of b minus acceleration of a, which is going to be 6 minus 4, or 2 foot per second square, and again along that incline. To find the velocity of point C, absolute velocity of point C, I'm gonna use another constraint. How should I relate z to the length of this cable? I can use this fact that this distance, for example, this length of the cable is a constant length, right? Because point C is on the cable. So the length of the cable from point C to this end of the cable is gonna remain constant. Let's call that L1, that piece of the cable. The length of it is L1. L1 is gonna be equal to, from here to here is x minus z, and from here to here is gonna be x minus y. So plus x minus y plus bunch of constants. Again, if I take a derivative of this, I'm gonna have 2x dot minus y dot minus z dot is equal to 0. And z dot shows the velocity of b. So if I put the numbers for x dot and y dot, I'm gonna be able to find z dot, which is the velocity of point C, and it's gonna be equal to 2 times 3 minus y dot, which is 2. So 6 minus 2 is going to be 4 foot per second. The direction is going to be along that incline again.